Hi there, I'm Hao, and this is just another video of me solving random LeetCode problem. So we have a linked list problem today. We need to find the maximum string sum of a linked list. Um, so if we have a linked list like this, right, we're gonna have the sum of each pair, right, uh, in this order, right. So the first node, right, the twin of the first node gonna be the last node. The twin of the second node gonna be the second to last node, so on and so forth, right? And we just have to find the max. So in this case, it's 6 and 6, so it's return 6. In this case, 7 and 4, right? So we return 7. And in the last case, only one pair, so we return 100,001, right? And we know that each value gonna be a minimum of 1, right? And it will be at least 2 nodes in the linked list. Right, and the length are always gonna be even. So the straightforward approach to this is we can do a stack, right? We can store everything in a stack as we iterate things through the linked list, right? And then as we can iterate through from index 0 to half the size, right? And as we iterate, we can take the sum of the element at the index, right? And the element at the last the last element, right? And keeping track of the max. So if we have a max, we can start up at negative infinity, right? And we can calculate 6. 6 is larger, right? And we keep going like this. So it's also going to be 6, so it doesn't change. So we return 6 at the end here, right? So let's code that up. So we have our start node as an empty array. We're going to return the mouse at the end. The mouse is equal to negative infinity. We also have our current equal to the head. The y per, right, per equal to per dot left. We need to store it into our stack, put it into our stack, put it down. Right, and we only want to iterate through half the node. And we just have to update the max. We can format the max of the max, right? And the sum as the current index, right? And then the twin. So which means it is a stack of stack dot length, like -1, -5. All right, let's try that. Okay, it is accepted. So using this approach is pretty straightforward, right? But this time complexity is O of n, but display complexity. So let's see, the space complexity is gonna be O of n, right? O n space. Because we need to use a stack to store our node, right? So there's a better way to do this in just O1 time. O1 O1 space, sorry. So we can do that by reverse the second half of the linked list. So if we have 5 or 2 and 1, right? Let's add another number 6 and 3, for example, right? Actually, let's do it like this. So 5 to 4 to 2 to 1 to 6 and then to 3, right? And this one is no, right? So if we so okay, the ultimate goal is that we can reverse half of the linked list, right? So the linked is coding this way for the second half, and left to right for the first half, and right to left for the second half, right? So if this is the case, and we can have the two head, right, and the reverse head. And as we iterate, we can compare the sum, right, and the max. So that is the goal. So in order to reverse the second half of the linked list, we first need to find the middle elements, right? So if the number of nodes are even, which is will always be, right? We always want to stop at the first middle node, right? So in that case, we can set the middle dot next, right, to be null to break the linked list into half. Right? So we can use a slow and a fast pointer. So why fast, right, and fast dot next, right, and fast dot next, right? We can keep iterating. So the slow pointer gonna go one step, and the fast pointer gonna go two step, right? So the idea is that if the fast pointer is moving twice as fast as the slow pointer, we will stop. By the time the fast pointer reach the end, we know that the slow pointer gonna be in the middle, right? Right. So if the fast pointer is moving twice as fast as the slow pointer, then by the time the fast pointer reach the end, we know that the slow pointer is in the middle, right? And the reason that we stop one step early here is because we want to stop at the first middle element. Okay, so the slow pointer go one step, right, and the fast pointer go two step, right? One step, two step, right, and it is null, right? Right. So if we don't stop one step early, right, then the slow pointer gonna be here, and we don't want that, right? Because we want to be able to break the linked list into two halves, right? So we always um check for one step ahead, right? So if the fast.next.next is null, then we stop. Okay. So again, slow is here, right? Fast is two step, which is here. Very slow go one step, and fast go two step, right? Now the fast.next.next is null, right? So we just stop here, right? And then we can set the slow.next to null, right? But before we do that, we need to keep track of the next element, right? Because we want to reverse it later. So we can set the previous to null, right? And the current to slow.next here, right? So we can set the slow.next to null here. So this is one linked list now. It is will be separated from the second half of the linked list. So now as we iterate, right, we can just set the curr.next equal to previous, right? Which is null here. Right. Right. So if we set the current dot next equal to the previous, we will lose track of the next node, right? So before we do that, we need to keep track of the next node, right? So we need to keep track of the next node. The next node is here, right? Equal to current dot next. So we can set the current dot next equal to null, which is the previous here, right? And we set the previous equal to the cur, right? And the cur equal to next, right? Similarly, we keep track of the next, right? And we set the cur.next equal to the previous, which is pointing at one here, right? We set the previous equal to the cur, and we set the cur equal to the next, right? And we keep going. We keep track of the next, which is null, right? Cur.next equal to previous, right? And then previous equal to cur, and then cur equal to next, right? And now cur is null, so we should stop, right? Now we are done, right? We are done. We have successfully built out two linked lists here, right? The first half of the linked list is from left to right, and the second half of the linked list is right to left, right? So we can have the left and the right here, right? And as we iterate, we can keep track of the max, right? Starting out at negative infinity, right? So 3 plus 3 is 6, right? So that is larger, and we can do left equal to left at next, right equal to right at next, right? So on and so forth. we find a new maximum, right? Which is 10. 4 plus 6 is 10. Right? Or the 3 is smaller than 10, so we don't do anything. Right? Right. And at the end, we can just return the max here. Right. Another thing that we have to do, that I forgot to mention, is that we need to keep track of the uh, as we fighting as we are fighting the middle node, right? Before we reverse it, we find the middle node, right? So when we find the middle node, we should also keep track of the size, right, of the link list, of the half of the size, so that we know how many iterations that we have to compare later on. Okay, so let's code this up. So we have, so the first step is to find the middle node, right? So this is calculate the half of the size, right, and middle node. So let's slow equal to the head. The fast factor is also equal to the head. And then we need half size starting at 1, right? Because the flow is already equal to the head, and that is counting as one node, right? So like fast, and then fast at next, right? But we want to stop one step early, right? We want to find the first middle node only, so we can break the link into half. We also check for fast at next, right? Fast is just only 2 steps, while the slow gonna go only 1 step, right? If the fast go in as fast, and by the time the fast is at the end, slow is in the middle, right? And we also keep track of the half size, right? After that, we need to reverse the second half of the link list. Right? So reverse is 0, and then the current is equal to the slow that max, remember? And we have to break the link list into half, right? So we set the slow that max equal to 0. So y per, right? We have to do per dot next, right? Equal to previous, right? Which is starting out null here, and then we update our previous equal to current, right? And then per equal to next, right? So before we set the next pointer, right, we need to keep track of the next node. Otherwise, we're gonna lose track of it. So const next equal to current dot next, right? If we set the current dot next equal to previous, we cannot get to the next node. So that's why we need to keep track of the next here, right? We just reset the next pointer of the current node, update the previous and the current pointer. So now the linked list is reversed. We have two linked lists, one going from left to right and one going from right to left, right? And now the only thing left to do is just to find the maximum, right? So we have the left. Let's call this left and right. Right, left is starting as the head, and the right gonna be starting at the previous, right? Because by the time the current node is null, the previous is gonna be the last node, right? Okay, and we also need the max starting out at negative infinity. So how many times are we iterating? We are only iterating half the size, right? Equal to 0, less than half size, and I plus plus, right? So we just have to update our max, right? Not max, the max, and the log of value, like plus the log of value. Right? We compare the current sum to the maximum, and then we just keep going, right? Left at next, and then right equal to right at next. Right? And at the end, we can just return the next. Right? So we're only using constant space here, and it worked. Thank you for watching.